Next set we're going to look at are the remainder of the rack itself. These are not differential tests in the traditional sense in that we added things. These are differential tests in that the media is selective and there's a differential test added to it. So let's start with citrate. This is what our control citrate looks like. A nice green color. And here's what two bacteria look like. This is our Citrobacter friondi. Has a nice blue color. This is our Proteus. Green color. And our E. coli also has a blue color. Blue in this case indicates that citrate is used. Next one we're going to take a look at is called TSI, or triple sugar iron. Here's what a control looks like. Here's what the E. coli looks like. It can use at least one of the sugars in the triple sugar iron. It does not reduce sulfur, but it does create gas. You can tell it creates gas by this air bubble that is seen inside the butt of the test tube. This is Proteus. This does not ferment the sugars, but it does reduce the iron down to sulfur. You can tell by its black color. And this is Citrobacter, where you can tell there is some reduction of sugars. It's not a full positive, but definitely a reduction of the iron down to hydrogen sulfide. And while it's difficult for you to see, this here, which looks like a smudge, is actually gas production. So this one will be positive for gas production, positive for hydrogen sulfide production, weak positive for sugar fermentation. Next, we're going to take a look at our tubes. Now, a control tube for all of these looks like this, with no bubbles inside the Durham tube. We're going to start with dextrose. And this is our Citrobacter. As you can see, there is fermentation and there is gas production inside the Durham's tube. This is the Citrobacter. As you can see, little gas production, but fermentation of dextrose does happen. Our E. coli, gas production, plus fermentation. Next one is going to be our glucose. No, lactose. Yeah, lactose. This is lactose. I just got these out of the fridge. Again, here's our control. This first one is quite interesting. It's interesting because of its color. This is Proteus. Red. This is a negative, no gas production. E. coli for sucrose. Lots of gas production and fermentation. Citrobacter. Some gas production, did have fermentation. And finally, excuse me, now we're going into our sucrose. Those are all lactose. This is sucrose. Sucrose for Citrobacter. Some gas production. No gas production. Weak fermenter. Why is it weak? It's an orangish color as opposed to a yellow or a red. Since this is an orangish color, this is a weak fermenter. It's Proteus vulgaris. And this is E. coli with some gas production, but definitely fermentation. This is urea. This is to see if it is able to utilize urea as part of its life cycle. metabolism, I should say. Here's a negative. This is E. coli. This is a weak positive, Citrobacter. Tell it's a weak positive because it's mostly yellowish orange, but there is a bit of pink up here. Now this next one is Proteus, and it's a strong positive. Look at that color. Much more of a magenta pinkish purple than the orange that was before. Final thing we're going to look at is gelatin and gelatin hydrolysis. Now, I took these out of the fridge. If this is a positive, there will be a section up here where the bacteria was that isn't solid when you turn it. So we put it on its side. Since there isn't a slant, this is a negative. As expected, that's our control. This is Citrobacter. Nothing. This is E. coli. Nothing. And Proteus. Negative.